Welcome back, friends. Thank you for joining Irgoi Learning. Myself, Dr. Sonal Desai. I am here with you to learn Energy Plus and Openstudio Energy simulation softwares. In a previous video, we have seen what is thermal zoning, how thermal zoning is done. We have also noted some thumb rules related to thermal zoning. Followed to that, we have learned about 3 types of HVAC system defined in Openstudio software. So in coming videos, let us implement this HVAC system to understand Openstudio simulation process. Right now, what you see in front of us is one old file which was made for a primary school model, and in that I am into HVAC tab. So this particular tab on the left side, that is for HVAC system. When you click it, in front of you, different layouts or templates will be there. So to start with, I will click on this plus button, that is to add the template loop. Again, to clarify, in this video we are learning about adding a template to HVAC system method. So when you have done this adding of template, add HVAC system will be popped up, and in that you can see different templates. These templates are as per ASHRAE standards, and around 12 templates are there of different type, ranging from package HVAC or VAV HVAC and all. So let us add first of all package rooftop VAV with reheat, which is a most common type of system used. So you will have to select on add to model to select this. So when you do this and then when you check it, you can see that with VAV with reheat, 4 total loops are being added, and these 4 loops are central air handling loop, hot water plant loop, chilled water plant loop, and condenser plant loop. So this 4, 1, 2, 3 and 4, these 4 loops are being added when you have added a template of VAV with reheat system. Now when you have look at this layout, you can see that it has 2 parts. Upper and lower parts are there in this layout, and lower part represents demand equipment while upper part represents supply equipment, and both of them are divided by a dotted line. Then this template has conventionally added several objects in supply side. If you look at this, there is outside air handler which controls how much used air goes out of the premises and how much fresh air enters to the conditioned space. Then there is a cooling coil, there is a heating coil, there is a supply fan, and there is a controller, that is for set point controller. On the demand side, you can see that there is a zone splitter and a mixture. So a zone splitter splits up this into 2 parts, and mixture merges these 2 streams into single part. Now the new air handler must be connected to one or more than one thermal zones. So to add this thermal zone, we have to either click on either of the zone splitter or a mixture. So if I click over here, I'll get on the right side, you can see that different zones which are already defined in this model, they are being popped up. These 3 models are classroom, corridor and miscellaneous. Let me have adding 2 zones to this model. So when I click this 2, you can see that after clicking this 2, the air loop updates to 2 demand side branches. One is for classroom zone and second one is for corridor zone. This can also be done by going through My Model section. In a My Model section, you can see over here thermal zones are there. So either you can add from here or you can directly select this classrooms and drag it over here and corridor to over here. So in either way, zones will be added to the model. Now, what this symbols as well as nodes represents, that we will see in the next video. Friends, we have seen how to add VAV with reheat template in previous video, and now we can see that two zones are added over here. One is classroom zone and another is corridor zone. Now to go further, we should know what this symbols on these two layouts means. On supply side as well as on demand side, there are different equipments and there are certain nodes. The circular points are called nodes. So what they means, that is discussed in this video series. So if we click on any icon, it will present the properties of the object. Say for example, this is cooling coil, and if I click on this, then the details of this, they are available in the right side window. Just like that, when I click on this air handler, air terminal stage, then again it will show the properties over here. So for each and every object, when I click on that object, it will come up with this type of information that gives details of that particular system. You can also note over here 3 subtabs are there. These are the general properties. These are the linkages, that is, it is connected to which loop. Further, whether it is connected to hot water loop or condenser loop. So that is mentioned over here, and when you click over here, that is about controller of this particular component. So wherever or whatever applicable, those subtabs will be activated on this. Then these nodes are the little symbols. They are scattered all over the diagram or the loop, and they are used to separate the objects in the loops. So this nodes represents points where properties of fluids like humidity, temperature, flow rate, refrigerant or water flow rate or air flow rate, they can be reported. So these nodes are associated basically with the control points, and managing nodes and construction between object is very tedious in GUEnergyPlus, but it becomes easier because here it can be graphically managed in Openstudio. So Openstudio take care of this tedious task, and they can be added or removed easily. So with each and every object, you can see there is one cross button. So when you press this, we can remove this particular component. And if you wish to add some additional components, say for example, if you wish to add heat recovery system, then you can add it from my model to this by simply dragging to the loop. Then it is always a case that each and every component will be connected to some other loop, and it can be noted by it can be achieved by simply pressing this nodes to related to upper side or lower side node of the system. So say for example, air handler is connected over here. This is air handler, so that is connected to the chiller. When you press over here, it's not connected, but if you press this cooling coils, then you can see that it is connected with the it's not connected, but if you press this cooling coils, then you can see that it's air handler, so that is connected to the chiller. When you press over here, it's not connected, but if you press this cooling coils, then you can see that it is connected with the uh, chiller water loop over here. So you can see that it was earlier on the supply equipment side and now it is on a demand side. So how the air handler is connected with the chiller equipment loop, that is shown over here, and when you press this button it will go back to the original loop or layout. So this was connected, but if you press this cooling coils then you can see that it's not connected, but if you press this cooling coils then you can see that it is connected with the uh, chiller water loop over here. So you can see that it was earlier on the supply equipment side and now it is on a demand side. So how the air handler is connected with the chiller equipment loop, that is shown over here, and when you press this button it will go back to the original performed by auto sizing. It means that flow rate of refrigerant, air or water, heating and cooling coil capacity, fan size, and other capacity related parameters, they are automatically determined by GUEnergyPlus engine using the sizing algorithm. Now this sizing algorithm is basically a cascading process. First, a load calculation is performed for each thermal zone. As we have seen previously how this load is made of. The load is made of internal and external parameters, like there will be external load due to heat transfer across the wall. Then there will be internal load due to equipment as well as occupants. So based on this load, thermal zone load will be decided. Also it will consider extreme weather condition, that is high temperature in summer and low temperature in winter. So this process is just like ideal air load, and it is identifying the energy required to maintain a particular cooling or heating set point at peak load conditions. So all of these thermal zone loads which are related to HVAC system, they will be added to one and all, and it will arrive on the total system load. This individual component sizes are computed using this total load as a starting point. Once it is known that this is going to be the total load, from that point individual component sizing like cooling coil watt or heating coil wattage or fan flow rates, they are been decided. So for forced air driven system involving fan, system sizing starts with calculation of airflow based on thermal zone. A load calculation and an assumed supply air temperature also will be calculated accordingly. In case of multi-zone system, as shown over here, that this system is connected to two different zones. So in that case, each and every thermal zone are added together and it will have a calculation of total supply air flow rate and supply fan efficiency. And finally, all computed airflow rate are used to design heating and cooling temperatures and size of heating and cooling coils. So auto-sized value, they need not to match exactly with the realistic systems. They are different from realistic available models in the market, and this sizing may be small or large compared to the available market value. So we cannot say that this auto sizing is a perfect way to judge HVAC capacity, but of course it gives a first-hand energy simulation and first-hand energy consumption view of a particular building. Now for auto sizing, there is one important related data is there, which is called design day file. As this auto sizing is based on extreme weather condition, and we need to define the DDY file. So if you remember in our very first module, when we have selected the weather file, at that time we have also imported this DDY file. So this design day file, they described extreme weather conditions, and Openstudio model contains this auto sizing HVAC system. They use at least one design day input to simulate without creating error. This DDY file is it has a different types of information, but they have design points for heating and cooling. And the working methodology is Openstudio imports only the subset condition to 0.4% summer design day point and 99.6% winter design day. Meaning of this statement is, in the summer month, the design temperature will only exceed by 0.4% of the time, and in the winter month, the temperature will remain above the design temperature for 99.6% of the hour in the year. So we have already defined this when we have started the model. So let us go back to HVAC tab, and we have already done this adding templates, but just to conclude, we will do this procedure again. As just said, this is a school model with 3 thermal zones already created, and now I am adding for 3 thermal zones, I am adding 3 templates of same type, that is package rooftop VAV with reheat. So I have added over here, and you can see by clicking over here, VAV with reheat is added. It already has one more VAV with reheat, so I'll add one more. So total 3 are required. So again I'll do package rooftop with VAV. So now if I check, I have 3 VAV with reheat, and now I have to add zones to them. As I have shown in previous model, either you can go to the edit mode and then add zone by clicking over here. You can assign a zone. So I am assigning classroom as well as classroom to this reheat 3, reheat 2. I'm assigning corridor to this circuit, VAV with reheat, and I'm assigning, this has already been assigned 2 zones. So first of all, I'll remove those 2 zones, and I'll assign the last mod zone, that is remaining one is miscellaneous zone over here. So this is how zoning can be done and template allocation can be done. And now one Welcome back, friends. We are learning about HVAC system for Openstudio GUI of GUEnergyPlus energy simulation software. We have discussed earlier that there are 3 types of HVAC equipment, and they are zone equipment, which can be added by templates. There can be air loops or there can be plant loops. So we will be talking about air loops in this video. And air loops are basically series of objects which are related to HVAC system that conditions the air which is provided to the thermal zone. So in case of cold days, hot air will be provided, or in case of hot days, cold air will be provided, or there will be some fresh air addition to the room. So that is all is handled by air loops. So let us create one empty air loop to understand how this air loop creation and addition is done in Openstudio interface. By clicking this plus symbol of the template, we can check, and there is an empty air loop available over here. So let us do add to the model. Now air always passes in the direction of the arrow mentioned over here, and as you can see, it has 2 parts: supply equipment and demand equipment. and we can add different components to the loop. These circles, they represent nodes, and these nodes are the locations where we can have properties of a fluid like temperature, pressure, humidity, flow rate, etc. Whichever applicable properties that they are available on the nodes. So now on this air loop, it is a closed air loop and it is not having any air exchange. So from library, let us add air loop HVAC outdoor air. So in the library, when we go for air loop, this is air loop HVAC outdoor air system. Let us add the one to this module. So now you can check that it is interacting with ambient air by rejecting the air as well as adding air to the system. So it is open system where some amount of return air will be exhausted and equivalent amount of fresh air will be replaced and it will be conditioned. Now, as just said, this has got two parts, supply equipment and demand equipment. And some nodes are there. This is called supply inlet node because air is entering to the supply equipment. So this is called supply inlet node, and same way this is called supply outlet node, while this is called demand inlet node and this is called demand outlet node. In the supply side of HVAC system, if we talk about just this upper portion, then their work domain is they have to allow air returning from the thermal zone via the supply inlet node. So all returning zone air, that is after taking care of one zone or multiple zone, this air will return back. So this supply equipment has to take the return air from this supply inlet node. Then it has to exhaust some of the air to air which has to go through heater through this supply outlet. Air to go out of the HVAC system. To continue further, we are going to learn in this video about adding components to supply side of air loop. We have seen two sides of heating and coil cooling water. So let me click coil cooling water first and I will add this coil cooling water to the nearest loop over here. So it will be added over here. So just like that, I have to add heating water coil, so it will be connected like this. Now if you see this library, there are many components and it is not possible that each and every component can be added to this air loop. See, for example, if you are looking for this absorption chiller and when you add over here, it will pop up with the error that this cannot be added over here, or it will give you non-competency symbol. So only the equipment which can be part of this loop, they can be added to this demand side and supply side loop. Now if you remember, we have seen that this plant loop also. To connect this to plant loop, we have to first select this over here, and when you select, so if plant loop is here, we can connect this to plant loop also. To connect this to plant loop, we have to first select this over here, and when you select, you can see that it will have edit button activated, and in the edit button you will have to click this second button, which is a linkage button. So when you click this plant loop, it means that now this click this second button, which is a linkage button. So when you click this plant loop, it means that now this cooling coil is part of plant loop also. So when you click on this, it will show that in a plant loop, this is a cooling coil over here. And you can see that this heating coil is not a part of plant loop because we have not done this exercise over here. If you do this over here, this can also be added, and when you check on this, it will show over here. So again, clicking on that will take back to our original system. So this is how we can add components, and we can connect this component or different equipment over here. Let us go towards demand equipment of the air loop. We have seen in previous session how to add this cooling coil as well as heating coil, and how to connect this cooling coil with the plant loop. Now if we talk about demand side, then the demand side of air loop has to manage three things. First of all, it has to allow the conditioned air to be taken up by this demand inlet node. This air from this node, it has to the mixture. Return air will merge to the mixture, and this return air will, and each and every zone should have air handler. So air from air loop is supplied to this zone through a unit which is called air terminal. So let us add one air terminal over here by simply dragging it over here. If air terminal is not there and simply it is connected to zone, then it will create simulation error. Hence it is required that presently there is just a single zone. So now from this thermal zone, or either from edit button over here, so we can add zone over here, and with each and every zone you can see there is air handler over here. So now the air will be splitted to two zones, and then it will mix back. Sizing of air loop. We have learnt about HVAC auto sizing in earlier videos. Required to achieve each is 104F for the for associated thermal zones and temperature set point for extreme days. We can check thermal zone sizing parameter when we click on this thermal zone over here. Thermal zone sizing parameter when we click on this thermal zone over here. And then if we check this cooling sizing parameter, we can check the zone cooling design supply air temperature. So it is for a cooling it is 57F, while for heating it is 104F for the classrooms type of thermal zone. So knowing this supply air conditions associated with a particular air loop may be assessed outdoor air and how to size. So basically air loops are primarily controlled by setting the temperature, manager warmest temperature. Then I'll select this and then add this to the loop, and then whenever air contains 3 and it provides free cooling, especially during night hours or during the myself Dr. Sonal Desai. I am here with the Openstudio. Welcome friends, thank you for joining Ergo e-learning. Myself Dr. Sonal Desai. I am here with the Openstudio GUI of GUEnergyPlus energy simulation software. We are learning about HVAC system, and in the HVAC system in previous video sessions we have seen how to add air loop. Going ahead in this video we are going to add plant loop. Basically a plant loop is a series of objects that represent a hydronic piping system inside a building. Hydronic piping system basically handles water, and this can be a supply hot water, chilled water, condensate water, and this water reaches to different HVAC components inside the building. These components turn this water into a service like heating of the room or cooling of the room, or a particular application can be served. So what you see in front of you is a plant loop, and just like air loop, plant loop has also two parts: supply equipment side and demand equipment side. So the one above the dotted line is supply equipment and the other below the dotted is demand equipment. Now, if you are looking at this supply side, then the role of supply side is to take back the water which is returning. This returning water goes from the HVAC equipment to this supply node. This is called supply inlet node and this is called supply outlet node. Then this water will go to the respective equipment and whatever requirement is there, that will be fulfilled through chiller, heater, there can be a boiler. So heating or cooling of the fluid up to correct temperature will take place and then supplying back this to the HVAC equipment through this supply outlet node. The supply side components may be added to the loop between supply inlet and outlet nodes, just like what we have done previously. Here also it can be done. So let us add few components. Here there will be a chiller. So let me add a chiller electric. Let me have water cooled chiller. So I am adding this to this node. With chiller there has to be a pump. Okay, let me add two chiller in parallel to understand this properly. And with respect to this chiller, I will need a pump. So here there are options that pump with variable speed or pump with constant speed. As of now, I'm just going with constant speed pump. So I'll add a pump over here and over here. I can also add this pump over here and then it will be called a supply line pump. And if I add pump over here, it will be called loop pump. So if I have basic understanding about this system, then the walkthrough through the process is like this. Water enters the supply air side inlet node and travels to this splitter. This splitter basically splits the water flow to the different path or branches. The flow is divided between this, right now two chillers are there. So flow is divided between two chillers based on the control sequence. And these chillers will cool the water and the supply mixture will recombine this flow. This is called mixture. So it will combine the flow and this water exits the supply line and then it goes to the supply node. Just like in air loop, as fan is required, here pump is required. So if pump is absent, then the simulation error might come. And as just said, these are the loop pumps, while these are called this is the loop pump, while these two are called branch pumps. And apart from this, many other equipment can be added in this circuit. Like we can add boiler, we can add cooling tower, we can also add fluid cooler, or we can add heat exchanger. Some heat recovery devices are there, so that can also be added. And by simply adding drag and drop option from this right side panel, we can add these different components. But at the same time, all the components are not possible to be added, and if we do so, there will be error if we add some irrespective equipment to the circuit. Loop demand side management. We have seen in previous session how to manage supply side of plant loop, and we have learnt about how to add chiller as well as pump. So if we look at the demand side, you can see that demand side is responsible for returning conditioned water from supply side through this demand inlet node. This is called demand inlet node and this is called demand outlet node. Then distributing this to the building's HVAC equipment. Presently this is empty. We can add over here HVAC equipment and then return the water to the supply side through this demand outlet node. So here basically stands load, whatever it is used for. Demand side of plant loop includes, just like air loop, here again there is a splitter and there is a mixture. So the role of splitter is to distribute inlet water to multiple branches, and mixture is to combine back this water and then dispatch it towards this loop. Like the supply side of plant loop, the demand side also includes a splitter and mixture, and splitter distributes incoming water through multiple branches. The mixture recombines the flow from the branches before returning it to the demand outlet node. So let us add some equipment over here, cooling coil over here. So let me add a coil cooling water. If there are multiple, we can add like this. So now if we look at the entire cycle, role of the entire cycle is this node takes back water, it conditions the water as per the requirement, pumps the water. This conditioned water comes to the cooling coil, then it gets distributed to the respective coil, and then again it will be going back. So this is how the entire cycle is connected. We can also connect this to the we can add over here, we can link them to the respective air loop wherever it is applicable, and we can complete the cycle. Now, if we talk about sizing of plant loop, then just like air loop, this also takes place after the sizing of air loop. So very first thing is done is sizing of heat transfer equipment of air loops are done. Say for example, how much temperature and flow rate is required, that is decided in air loop. Then based on it, how much size of chiller is required, and based on that plant loop sizing can be done. So from the previous section, we have already seen air loop sizing process, which determines heating or cooling capacity requirement and corresponding air flow rate and design supply temperature. So then after this, cooling sizing, plant loop sizing is done. Also, we can add different controls like we did for air loop. Here again, we can add plant loop controls. There can be a temperature control added to plant loop, or there can be load equipment dispatch control added, or there can be a prescribing plant loop load ranges. So that is all possible. We will see them in the coming up modules. Thank you for joining in GUE Learning.